In this video, I will talk about how to configure mirror on drop or MoD on Enterprise Sonic. This is my second video in silicon-enabled telemetry series. In the first video, I explained what is mirror on drop feature. But in this video, we will focus on the configuration aspect of the feature, and I will also show you a demo of this feature using an open source collector. Let's make a start. Mirror on drop or MoD is a Broadcom silicon feature that allows real-time drop monitoring for your business critical applications. MoD tells you what is impacted, so which application and user group is impacted. It tells you where the packet drop is happening. So it tells you exactly the switch ID where the packet drop is happening. And it tells you why the packet drop is happening. So it gives you a drop reason. So mirror on drop, it provides your operations team with real actionable insight so that they can very quickly root cause and fix a packet drop problem. And this is all the configuration you need to configure MoD on your enterprise Sonic switch. So you go in the TAM mode, this telemetry and monitoring mode from configuration mode. So once you are in the TAM mode, you define a switch ID for the switch. This is any decimal number. Then you define collector. Where do you want your switch to send these MoD messages? This collector could be, there are multiple commercial solutions available for collectors. So there is a very good monitoring solution from Broadcom called NetOps. There is also a solution, for example, from Octera AI, which can monitor MoD messages. But in this demo, I am using an open source collector. And for me, this collector is on this particular IP, and it is listening for MoD messages on this particular port number. With the sampler command, you define your sampling interval, which should be 1 for MoD. And flow group is probably the most important command. This is the command where you define your interesting traffic. So remember I said that MoD monitors your business critical application. But the question is, what is your business critical application? Answer is what you define with the flow group command. So with this command, you can use layer 3 parameters like source and destination IP, protocol number. You can use layer 4 parameters like port numbers, or even you can use layer 2 parameters like VLAN ID and ether type. So there is a lot of granularity and flexibility in how you can define your interesting or business critical application. Then you go in the drop monitor mode. This aging interval is an optional command. Session is the most important command here. This is the command where everything comes together. So with this command, you are saying that I want to monitor this particular traffic. And if there is any drop in that particular traffic, send that information to this collector at this sampling interval. And then you enable this feature. And that's it. That's all the configuration you need to enable mirror on drop on Enterprise Sonic. Now, before I jump into the lab, I want to show you my lab setup. So what you see in the middle here, this is a graphical representation of the open source collector I was talking about. You can see it comprises 4 modules. Each of these modules is open source, as you can imagine. So this Packet RX app, this is basically an input plugin in Telegraph. This plugin allows Telegraph to decode MoD messages and understand the various metrics provided. Telegraph is our data collector agent. InfluxDB, I'm sure you all know, this is the database that we're using here, open source once again. And Grafana is our visualization tool. So I'll show you, we have created a specific dashboard in Grafana, which is used to display all these MoD metrics. On the network side, in my lab, basically I have these switches, which are based on Broadcom silicon. There are different type of Broadcom silicon which can support MoD, mirror on drop feature. Trident Tomahawk, Jericho, and so on. In this particular lab, I'm using Trident 3 base switches for my demo. I'm running this open source collector on a Linux machine in the lab, and I will be generating some traffic which is defined as interesting traffic on my switch. The switch will drop those messages, and then we will see on the Grafana dashboard why those messages were dropped. So let's jump into it. Okay, so this is the Grafana dashboard I was talking about. Some of the important fields here. So this chart will show us total active drops, how many flows are being dropped at this point. This chart will show us how many switches are reporting the drop. And this drop anomaly percentage, this is basically how many drops you are seeing compared to your baseline. And your baseline is the number of drops you have seen over a period of time. And this period of time can be defined. You can choose period of time from this drop-down menu, and it can be few hours, months, or years. In my case, because it's a lab, I'm just choosing 5 minutes. And this current drop, this is the section where we will see what are the drops happening. And in the history of the drops, historical drops table, you will see what drops were seen in the past. Okay, so let's now look into our switch. So this is the switch where I have configured MoD. So I'll go in the I'll look in the running configuration for telemetry and monitoring section. This is the switch ID that I've defined. Let me clarify one more thing. The switch ID shown here is in decimal, but the switch ID that is shown in this Grafana dashboard, it will be in hexadecimal. So you will see a conversion there. I've defined a collector. I've defined my interesting traffic. In this case, interesting traffic is any traffic which has this subnet as the destination. And the remaining configuration is very similar to what I have already shown you. Okay, so now what I'll do is I will send some traffic which will be interesting traffic, but which will be dropped by the switch. So this is, I'm using some traffic generator software on my Linux machine. So I will send first traffic that I'm going to send. It will be, its definition will be that it will have the same source and destination IP. What type of traffic is which has the same source and destination IP? Answer is it's not a legitimate traffic, right? So this is basically a definition of a DOS attack. So Broadcom Silicon is going to identify that, look, source IP is equal to destination IP. This is some dodgy traffic. I'm going to drop it. Once the traffic is dropped, because this is interesting traffic, because it falls in the same destination subnet that I defined on my switch. So this is interesting traffic or business critical traffic for my switch. A MoD message will be generated when the packets are dropped, and we will see it here. So there we go. I am going to send this traffic now. So packets are being sent, and we can see that one active drop is there, one switch is reporting, and there we go. This is the information we are getting from the MoD message. So the switch is sending this MoD message, which tells us what is the switch ID. It will appear again, don't worry. There you go. So that 33333, if you convert it from hex, from decimal to hex, it comes out to be 8235, right? So this is the switch ID. It tells me the protocol number, source and destination IP, port numbers, and very important, it tells me the drop reason, why that packet drop is happening, because this is the definition of a DOS attack. And you can see source IP, we can see in the historical data, the source IP is equal to destination IP. So this is not legitimate traffic. That is why the traffic was dropped. Okay, Now send the second type of traffic. The second traffic that I've defined here, second flow that I've defined here, it's not illegitimate traffic, it's valid traffic, but it will be sent for a VLAN which has not been configured on the switch. So there is missing configuration. And this is a type of problem which can happen in any network, right? You can just forget to configure a VLAN on one of the switch, and or during a change you erroneously just deleted that VLAN. So this is a human error problem which can happen in any network. So let's simulate that problem here, and there you go. It tells us that there is another packet drop happening. So now there are two type of packet drops happening, and the second one is unknown VLAN ID. Right? So you can see, you know which application, you know the source and destination IP and port number, you know which user group because you know the destination IP, you know where this traffic was supposed to go, you know exactly where the packet drop is happening. So you have the switch ID information, and now you know the drop reason as well. So now your operations team can look at it, and they will know exactly where to go and how to fix this problem. Hopefully you can see this is a valuable feature, and hopefully now you understand how to configure this on Enterprise Sonic. Thanks for watching.